Download this code from codegive.com, link in the description below. Understanding size in arrays, especially in programming. This tutorial delves into the concept of size when dealing with arrays, particularly from a programming perspective. We'll explore various aspects like array length, memory footprint, element size, and how different programming languages handle these concepts. We'll use code examples to illustrate the concepts, focusing on common languages like C, C++, Python, Java, and JavaScript. 1. What is size when referring to arrays? The term size related to arrays can refer to several different things. Length the number of elements the array can hold. This is often the most common meaning of size when discussing arrays. It's typically determined when the array is created. Memory footprint, or size in bytes, the total amount of memory, in bytes, that the array occupies in memory. This depends on the number of elements and the size of each element. Element size the amount of memory occupied by a single element within the array. This is determined by the data type of the elements. Example: an integer takes up more space than a character. Let's break down each of these aspects with code examples. 2. Array length, number of elements. The length of an array is the most straightforward concept. It indicates how many elements the array can contain. C/C++. Explanation **int numbers 5, declares an array named numbers capable of holding 5 integers. Size of, numbers, returns the total size in bytes of the entire numbers array. Size of, numbers 0, returns the size in bytes of a single element, an integer in this case. Dividing the total size by the size of one element gives you the number of elements, the length. This is a common way to determine array length in C/C++. Python. Explanation Python uses the built-in len function to determine the number of elements in a list, which acts like a dynamic array. Java. Explanation Java arrays have a length property that you can directly access to get the number of elements. JavaScript. Explanation JavaScript arrays, like Java arrays, also have a length property. 3. Memory footprint, size in bytes. The memory footprint is the total amount of memory an array occupies. It depends on the number of elements and the size of each element. C/C++. Explanation size of, numbers, returns the total size in bytes allocated to the numbers array. Since numbers is an array of 5 integers, and an integer typically takes 4 bytes, the total size is 5*4 equals 20 bytes. Similarly, for doubles, an array of 10 double precision floating point numbers, the total size is 10*8 equals 80 bytes, assuming a double takes 8 bytes. Note the use of %0 in printf, which is the correct format specifier for size_t, the return type of size of. Python. Python doesn't offer a direct equivalent to size of like C/C++. You can use the sys.getSizeOf function, but it includes overhead due to Python's object model. It doesn't give you a precise measure of only the data storage size. It's generally more useful for comparing the relative sizes of different data structures. Important notes about Python ***. Python lists are dynamic arrays. They can grow or shrink as you add or remove elements. Therefore, the sys.getSizeOf result may not perfectly reflect the storage size of just the integer values themselves. It includes the list objects overhead and pointers to the elements. Asterisk for more precise memory measurement in Python, especially when dealing with large numerical arrays, consider using the NumPy library, which provides efficient storage and operations on arrays. Asterisk Java. Like Python, Java doesn't directly expose a mechanism equivalent to C's size of. You can't easily get the exact memory footprint of an array alone because of the Java Virtual Machine, JVM, and object overhead. You can estimate each element will take up a certain number of bytes depending on its type. For example, an int takes 4 bytes, a double takes 8 bytes, etc. The array itself also has some overhead associated with the JVM. Explanation asterisk. The code provides estimates based on the standard size of primitive data types in Java. It doesn't account for the array overhead. Asterisk JavaScript. JavaScript, like Python and Java, doesn't provide a direct way to determine the exact memory footprint of an array. Memory management is largely handled by the JavaScript engine. Similar to Java, you can estimate based on the data types stored in the array, keeping in mind that JavaScript numbers are typically double precision floating point. 4. Element size. The element size is the amount of memory occupied by a single element within the array. This is determined by the data type of the elements. Asterisk C/C++. Explanation asterisk. Asterisk size of, int, size of, double, and size of, char, directly return the size in bytes of these data types. The exact sizes can vary depending on the compiler and architecture, but these are common values. Asterisk Python. As mentioned before, Python's object model adds overhead. sys.gets of will give you the size of the Python object representing the integer or other data type, but not just the size of the underlying numeric value itself. Asterisk Java. Explanation asterisk. Java specifies the sizes of primitive data types. Asterisk int, 4 bytes. Asterisk double, 8 bytes. Asterisk char, 2 bytes, because Java uses Unicode. Asterisk boolean, implementation dependent, but typically 1 byte. Asterisk JavaScript. In JavaScript, all numbers are typically represented as double precision floating point values, 64 bits, or 8 bytes. Strings use Unicode and can have variable sizes depending on the characters they contain. There's no direct size of like operator. 5. Arrays of objects/references, important considerations. When you have an array of objects, or, more precisely, references to objects, the memory footprint calculation changes slightly, especially in languages like Java and JavaScript. Asterisk Java asterisk an array of string objects, for example, doesn't store the actual strings directly within the array's memory. It stores references, pointers, to string objects that are located elsewhere in memory, on the heap. Therefore, the size of the array will be determined by the number of references it holds, where each reference typically takes 4 or 8 bytes, depending on the JVM architecture. The size of the string objects themselves is separate. Asterisk JavaScript asterisk the same principle applies to JavaScript arrays of objects. The array stores references to the objects. Let's illustrate this with Java code. 6. Using NumPy for memory-efficient arrays in Python. If you're working with large numerical arrays in Python and want more control over memory usage, the NumPy library is essential. NumPy arrays store data in contiguous blocks of memory, leading to better performance and more predictable memory footprints. Explanation asterisk. Asterisk np.array, 1, 2, 3, 4, 5, type equals np.int32, creates a numpy array with the specified data type np.int32, 32-bit integers, which is 4 bytes each. The array stores the integers contiguously in memory. Asterisk numbers.n bytes provides the total number of bytes occupied by the array. Asterisk numbers.itemsize gives the size of each individual element. 7. Dynamic arrays, lists in Python, ArrayList in Java, etc. Dynamic arrays, like Python lists and Java ArrayList, automatically resize themselves as you add or remove elements. This flexibility comes at the cost of slightly more memory overhead and potentially less predictable memory usage compared to static arrays. Asterisk when a dynamic array needs to grow, it typically allocates a larger block of memory than it currently needs, copies the existing elements into the new block, and then deallocates the old block. This resizing operation can be relatively expensive. 8. Summary and best practices. Asterisk understand the context. Asterisk be clear about what size means in the context of your program. Are you interested in the number of elements, the total memory used, or the size of each element? Asterisk use the appropriate tools. Asterisk use size of in C/C++, len, in Python, .length in Java and JavaScript, n bytes in NumPy, or sys.getSize of, in Python, with caution. Asterisk consider data types. Asterisk choose data types that are appropriate for the values you're storing and that minimize memory usage. For example, if you only need to store small integers, using int8_t or short, in C/C++, can save memory compared to int. In Python, NumPy allows you to explicitly specify data types. Asterisk be mindful of dynamic arrays. Asterisk dynamic arrays are convenient, but they can have performance implications if they are resized frequently. If you know the approximate size of your data in advance, pre-allocate the array with enough space to avoid frequent resizing. Asterisk profile memory usage. Asterisk use memory profiling tools, available in most programming environments, to identify areas where your program might be using more memory than necessary. Asterisk object references. Asterisk remember that with object arrays, the size of the references is what determines the array's memory footprint, not the objects themselves, which reside elsewhere in memory. This tutorial has provided a comprehensive overview of array size, covering array length, memory footprint, element size, and the nuances of handling arrays in different programming languages. By understanding these concepts, you can write more efficient and memory-conscious code. Remember to experiment with the code examples and adapt them to your specific programming needs.